Thank you. Yeah, thank you for the kind introduction. As Alex said, my name is Tobias Geyer. I tweet as the QA guy. I'm going to use my phone during this presentation, so you might see your tweets popping up on the screen later if you tweet at me. I'm an electrical engineer by training, and a tester by profession. Being an electrical engineer means I have not killed myself when building this contraption over here, but it will be part of the talk later. So, when I was, once upon a time, a long time ago, I was in school and my physics teacher showed that. Hands up, who knows what that is? Ooh, yay, a few people. It's an electrical circuit with a power source, a switch, and a light bulb. Everybody knows that stuff from home. You can use a switch to turn the lights on and off. If we were to test that, if you wanted to know if that stuff works, how many test cases would you come up with? Roughly, wild guesses. 1, 10, 100, 1,000? I'd start with 8 at least. We have a switch in 2 positions, on and off. We have a power source, power being there or not. And we have a light bulb working or not working. That's kind of the minimal thing you want to figure out if it's working. And I'm not going to run through all of those tests, but guess what? Switch is off, light is off, switch is on, light is on. Ooh, awesome. That's not IoT. But still, that's only half the story. Because we've got the power source down there, and most of us know power sources are not the same all over the world. We have 220 volts here in Europe, or 230. We have 110 volts in other states, all kinds of stuff happening. But that's not the only thing which gets tricky when we want to test. Because that switch here also gets tricky. And now it's a dangerous part of the demo because it not always works. But I want to see if I can get it to work. Nah, crap. Because the switch is analog. It may look like it's binary on and off, but if you just find the right position, a light bulb starts flickering, starts turning. I can't get it to turn half on. Feel free to come up later and try this out. Ah, come on. It worked so well when I rehearsed this. Okay, I'll stop it. But you can actually turn light bulbs half on if you get the right switch position. I don't recommend you to do this at home because you might kill your fuses. I didn't kill the fuses here. I'm really happy about it. But that just shows there's more to even simple stuff like that. Now the good news is we have the IoT. We have IoT light bulbs. Ta-da! No more switches! Awesome. Test cases reduced. That's brilliant. Makes all of our lives easier. That is the Philips Hue architecture. We have an app and API endpoints over here, which connect to something called an APG Edge. No clue. Talk to client Eastwood via Redis, via Golden Gate and Freddie Mercury, over HTTP to a bridge, the Golden Gate bridge, via Zigbee to a light bulb. So that's easy. And that's ignoring all of that. How are we going to test that? How are we going to get a handle on that? And by the way, what is all that stuff? So if you're testing in an IoT project, it's really easy to become overwhelmed and just see all this new technology. I don't see any Eclipse technology, but I've heard so many terms and technologies over the last day and the day before that I don't even know what the terms mean. This stuff is even more complicated than flipping switches here and working with voltages. So what can we do? I started research. I read a ton of articles and just noted down the keywords which seemed related to testing. You don't have to read all of that. But a few things pop up all over the place. And that's security, 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 security. Seems to be important. Everybody's talking about it. Performance, 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 performance. also kind of important. That's good to know. But there's more. There's data protection, scalability, connectivity. We have UI testing, robustness, user environments, creativity, crowd testing, DevOps, usability, the list never ends. Nobody has all of those skills. Feel free to fight me on this, but I believe nobody has all of those skills, especially not to a depth, to an extent that you could do real in-depth testing in all of those areas. You may be a really good automation tester, you may be a really good performance tester, but having all of those skills in one person is probably not going to happen. So what are we going to do? Because we still have to test that stuff, we still have to somehow make sure it works. And by the way, I forgot the second part of my demo. Isn't that nice? Because what I wanted to show, it works. I brought my own Wi-Fi, that's why it's working. But yeah, the light bulb is actually working. I can turn it on and off with my phone. But if I want to make sure it really works, if I want to test that, what am I going to do? The solution I came up with for myself is I just started. That looks really bad on this projector. Okay. We have 3 layers of skills, and they build on top of each other. We have what I consider basic skills, we have testing skills, and we have technical skills. And all of those are needed for testing in the IoT. And basic skills, to me, are learning, teaching, and collaboration. Because, as you've seen, there's a ton of stuff happening. There's a gazillion Eclipse projects dealing with IoT. There's more stuff which is not Eclipse. In the slide, there were many names which I did not know what they were. What was a client Eastwood? What was the Golden Gate? I recognized one name, Redis. I Googled it. It's a data storage, stores key value data. Okay, now I know more. But that's exactly the point. You are faced with a lot of stuff which probably you have no idea about. Try to learn it. Doesn't mean that you have to be able to build the whole thing. Doesn't mean that you have to be able to connect to an MQTT broker and send it data, receive data, but it would be good to know what MQTT is, what it does, because that can guide and inform the testing that you do, and it helps you to ask better questions. Now, what I did, and the way this relates to my little IoT light bulb over there, I learned something at another conference from Santosh, who's unfortunately not here today, because he talked about security testing in the IoT, and he showed us that it's really, really easy to decompile Android apps. Now, this is an Android phone. What I did is, I followed his instructions, I had learned from him, and I decompiled the Android app that controls this light bulb. First thing I noticed, hey, cool, they shipped the JUnit framework to all the end customers. The tester in me hopes that this means they do have automated tests. The tester in me also wonders if they do this to bloat up the app, if that stuff should be in there. I'm confused. But I also found another class in here, which is called API URL provider. Now that sounds like fun. And if you look into those class, we see a ton of URLs. And we see mobile API URLs, we see mobile MQTT URLs. Now that looks like stuff we can play with. What's also interesting is we have these URLs ends in CN, US, and EU. So depending on the region you're in, apparently you end up at different URLs. Is that something which is a test case? What happens if a customer buys the light bulb in the US, connects it, uses it, and then moves to China? Can he still use it? What happens to the data that has been stored in those clouds? The good news is, all the API documentation for this cloud is online. So that's even better. So you don't have to dig around in the Android app anymore. We can look at the cloud documentation, we can learn how all that stuff works, and we can then come up with proper test cases. I wanted to hack together a small Java application connecting to that stuff and making my light bulb turn on and off. I didn't manage to do that because I failed to do a second thing. I didn't find anybody to collaborate with on that. But that's actually what helps a lot in testing. Yeah, next time. I'll talk to you next time. But it's the second point. You don't have all those skills. You can learn, and you can, but you can learn only so much. But you don't have to learn everything. Talk to people. If you're working in a team building IoT products, talk to your developers. Say, I have an idea, I want to test something, but I don't know how to do it. Can you help me? You may end up building a little tool. You may end up just you giving input for test cases, the other person running the test cases, implementing unit tests, whatever. Talk to each other, collaborate. There's so much going on here. There's so many technologies. If we don't talk to each other, if we don't support each other, we'll have a really, really hard time testing all of that stuff. And then, if you collaborated, if you learned something, also share the knowledge. Teach people. It doesn't have to be a conference talk, even though I'm pretty sure Alex would love to see more conference talks at the Project Quality Day, or even at the IoT playground and all of the other things going on here. Talk to people in the coffee kitchen. Hey, I found out that this piece of software, or this piece of hardware that you're using has an interesting edge case, has interesting implications. Did you know that as well? Share your knowledge. Help each other to become better. Once you've got that down, testing skills. I could talk about this basically all day. I trimmed it down a bit. Critical thinking. We're building IoT devices, we're building applications, and we're building that with a lot of biases and assumptions which you may not even be aware of. And critical thinking may help us to become aware of that stuff. Alex just gave a great talk where she mentioned diversity being a problem, like machine learning, learning with biased input data, producing biased outputs, biased neural networks. Be aware of the stuff that you use. Be aware of the assumptions that you have. Ethics, now this is kind of a favorite topic of mine. I gave a tutorial on it yesterday. IoT devices tend to end up, at least most of them, tend to end up in people's private lives. They're building smart homes with that. They're using it to water their lawn, whatever. There's a lot of data happening. There's a lot of data being collected in clouds. And you can do cool things with that. You can see how people are using the lights. You can build usage profiles. You can see if people are home or not at certain times of the day, if you have all the data. And you could probably come up with interesting use cases. The question is, are those things we should be building? We can build them, but should we? And that's something which we should all talk more about. Exploration, exploratory testing. Alex talked about this a few years ago. I don't know exactly how many. The whole landscape of IoT is moving damn fast. If you wait for a full set of specifications and requirements to derive a full set of test cases to execute the test cases and then provide feedback, your feedback loop is going to be so long, the results will be outdated before you've run all the test cases. Exploratory testing, being a good explorer, learning, experimenting with a system that you have is going to help you a lot more and going to yield a lot better results. And we can all benefit from being better explorers. Also, improving testability. It comes down to collaboration as well. You have test ideas, you want to test stuff better. It's probably not possible. Testing, I bought this light bulb off of Amazon. It's not exactly easy to find out what goes on inside that light bulb. I didn't want to take it apart, I have to admit. But if your team is building those devices, you can influence them and can say, okay, can we add logging? Can we add monitoring? Can we add hidden interfaces that I can use to drive my testing? But as a tester, we're the experts. We know what we need. We just have to convince other people to help us get that. And then user focus and experience of life is also a really important topic when it comes to testing in IoT. I annoyed the hell out of my wife when I got this light bulb, because I unpacked it in the evening. She was in the living room, she was watching TV, the lights were dimmed. I built a little contraption so I could start using it. Power on, and that thing starts blinking at full power in a dimmed living room. And that was a sign, yeah, please connect me to the Wi-Fi. I took out the instruction manual, started reading, followed a 20-step process in the app until finally the light bulb was connected and I could finally turn it off. She was not that happy. Who comes up with crap like that? I mean, it's a full RGB color light bulb. Maybe alternate between red and green or stuff like that, or if you want to care for the colorblind, alternate between different colors. But full power, on, off. If that light bulb ever breaks and I have to replace it in the night, I want to read the instruction manual while the light bulb goes on, off, on, off, on, off. Who came up with that? Even Facebook, that prides itself in not having any testers, starts hiring people which are not testers, but people that have experience in life, or as they tell it, have seen some shit. Because your users are gonna use those devices in unexpected ways. I know of a family that came up with a really interesting solution. They put an IoT light bulb in the kid's room. And they dim it at night, they turn it to red, dim it down, so you have a nice night light. And if the kid wakes up in the morning and the light bulb is still red, kid knows, my parents are still sleeping. I should rather not bother them. But if the parents get up, in bed, pull out the app, turn the light bulb green. Now the kid knows, okay, I can come over, I can jump into the parents' bed and bother them. I'm pretty sure that's not a use case somebody thought of when they were building that light bulb. Yes, it's supported, yes, it's working, yes, I tried it. But people are gonna do stuff with their IoT devices which you have not anticipated. So try to anticipate use cases and app use or misuse cases. And therefore, you need experience. You need people ideally with diverse backgrounds. Alex, in her talk, just gave the example which I was going to give as well. So I'll repeat her. The problem is many of those IoT devices are set up by men in relationships more often. So the husband knows how to control all that stuff, how to set all that stuff up. And if he feels funny, he takes the phone with him, changes the password. His wife's phone can't control the IoT devices anymore. His wife's at home, sitting in darkness. Haha, what a nice joke. If the couple splits up, and he still has control over the whole smart home system, that's a whole different story. This architecture diagram from Philips, and I'm pretty sure the other architectures don't look much nicer. There's so many moving parts. But there was this clear, happy path through the architecture of stuff that has to work for the user to be able to control the light or control other devices. As a tester, you could try to test everything. It's probably not going to work. So you need to do some risk assessment. What's the stuff that absolutely has to work? You don't have to do this on your own. Talk to people. What can fall off the edge? We had this duplicated system down here, Freddie Mercury and Golden Gate, I think. What happens if one of those is down? Does everything still work? Do we need both of them? What do I have to test? Try to do a risk-based testing approach on that stuff. You will not be able to test all of it. And at the end, we have embedded code happening here, running in the light bulb. We have an app running here. We have a cloud running, I don't know where, in China apparently. And there are different people, different developers with different skill sets working on that stuff. And everybody's seeing his area. As a tester, we have the opportunity, and I feel the obligation, to keep a holistic view, to see how things work together. What happens if X doesn't work? What happens if those two parts can't communicate? What do we have to do to make sure they can communicate? Try to keep the whole picture in mind. You don't have to be in the smallest details. There, again, you can collaborate with people. But you can be the one reminding everybody, hey, that's what we want to do. And wouldn't it be nice if the feature, if we have a mobile app and an Android app, if the features felt the same way, we could do the same things in the same way? Try to give that holistic view. Sorry. Then we're on to technical skills. Simulation and tool building. Not every tester is a developer. I can code, but I wouldn't want to see my code in production. There are testers who are really good at all the stuff I mentioned and can't code at all. The chances are you're going to need to be able to simulate stuff. Now we have a cloud running here. I bought one light bulb. Even if you have a test lab and a budget for a test lab, chances are low that you're going to buy 1,000 light bulbs and do a performance test. Chances are high that you're going to simulate 1,000 light bulbs and see what happens to your backend. Simulate 1,000,000 light bulbs. Build some tools. There was a presentation on the IoT testware this morning. At least as far as my research went, there are no standardized test tools in IoT at all right now. There are approaches, there are people working on that stuff, but in web testing we have Selenium, and that's the standard everybody agrees on. If you want to test web applications, use Selenium, period. If you want to test RCP applications, use, for example, Jubula. That stuff is missing for IoT, so you end up building your own tools. Probably not building them yourself. Either you learn how to build the tools or you collaborate with people and then you end up with tools. Security testing. It's been mentioned all over the place. It's been mentioned all day. We're dealing with difficult data, with personal data. Those devices run in people's homes. We could come into all kinds of trouble if we don't have proper security in the whole chain of our IoT devices. That's also where we're back to collaboration. There's an OWASP project, the OWASP IoT Top 10 Open Web Application Standards Security Project. That's the abbreviation. And they have a top 10 list of IoT security issues. Unfortunately, that's a few years old, and they've promised to update it this year, which has not yet happened, but hey, we've still got a month. But look at that list. Try to catch the obvious stuff. At least make your things that you're building a bit more secure than what your competitor is doing. So the hackers go for the easy stuff. They leave you in peace, hack the other people's stuff, you're safe. But then again, get the experts in. If you want to have real security testing, at least that's my recommendation, get somebody in that knows what they're doing. There are many moving parts. Have people look at that know how those parts move, how those parts can misbehave. And that goes down to patch levels on Linux distributions on your cloud backend and stuff like that. I don't want to touch. Performance takes on interesting new meanings. I'm from a web application testing background. So to me, performance always meant, yeah, the pages have to render quickly in the user browser, and we should not overload the server. But if we overload the server, we just put up more servers and we're happy. In IoT, we have two performance points. We have device performance and we have the backend performance. And the device performance is, of course, response time. If I want to switch the light bulb on, it would be bad if it takes 5 minutes between me pressing the button and the light bulb turning on. And even with my tethered hotspot, that's not happening, which is a good thing. Whoop. Yeah. So, click, click. That's okay. Could be faster. My physical switch is faster, obviously, but I can't control the other light bulb from here, so I'm okay with a little delay. But I wouldn't be okay with a minute delay. 10 minutes, okay. But it also means battery consumption. Not every IoT device is connected to the main current. And we have temperature sensors which are battery-based. Now, if that battery runs out every 2 months, chances are low that you're going to buy that device again. Network utilization. Not every device is connected to the Wi-Fi. If you're sending logging data or any data all the time in a millisecond period, you'll end up saturating every network pretty easily. How are you using your network? Are you using it wisely? But also, of course, the same stuff we've had in the backend as always, as we've had in every backend system. Response time, resource usage is also a topic if we're talking about backend system. You can always scale. Amazon Web Services allow you to spin up new instances really fast, but those also cost money. So you may want to use your resources wisely. And there's also the question, how quickly can you scale? Just imagine this light bulb going on an Amazon Cyber Monday flash sale. All of a sudden it costs €1 to buy this light bulb, and 100,000 people buy those light bulbs in bulk, connect them, all of a sudden your backend system sees so many more connections. What's going to happen there? You may want to test for that. This is a firmware update for a toothbrush, which contains performance improvements and bug fixes. What a time to be alive. I can only imagine that they improved the battery performance on that thing, because otherwise, what is there for performance improvements on a toothbrush? But then again, what kind of bug fixes can you build into a toothbrush? And then there's hardware, user experience, what users do. I'm going to read this. I was totally confused for a second when I looked over at my travel charger and thought, did I really buy a charger from a company called Plus Juice and didn't notice? Is that some horrible pun on juice? No, it's upside down, and the company name is iSmart. Not smart. Try to look at your devices if you turn them around in all 3 dimensions. Somebody bought a device and as a result of that was felt dumb. Is that what you want to do to your users? I don't think so. But that's what happens. People use your stuff in unexpected ways. The chances are high that if there's a child in the household, I've got 2 children, I know how kids are, the kids will yank that off the socket and just start either chewing on them, jumping on them, throwing them out of the window, depending on the age. How do your devices handle that stuff? Should they handle it? You can always decide, okay, that's not even an abuse case that we're going to consider, but at least think about it. So, which kind of skills do we need? To sum this up a bit, I think what we need in testing IoT is collaborative, risk-based, holistic testing, kind of a buzzword bingo, I know, with a special focus on security, performance, and user environments. This should cover the basis. If you know how to test for that stuff, you may end up with a product that your users actually like, that's actually usable, and that they come back to get more of. How can you get those skills? A few hints. There's a training that we heard of today also, for example, by ASQF, the Quality Engineering for the Internet of Things. I had a look at the syllabus. It covers most of that stuff. I like that. I have not attended the training, so don't blame it on me if you don't like it. But the syllabus at least looks good. You can always download the syllabus and read it for yourselves. There's the OWASP Internet of Things project. They have great resources if you want to test IoT projects. The easiest thing, I believe, that you can do, stuff like that. That's a €25 light bulb on Amazon. I did not buy the cheapest one. If you want to go for easy successes in finding IoT bugs, just buy the cheapest light bulb you can find, plug it in, and you'll have a field day. But that's shooting fish in a barrel. That stuff's cheap. Just build up your own little small test lab, extend it from there. But it's a great learning opportunity. And it's fun. I had a lot of fun actually playing around with that and discovering awesome things that this light bulb can do, much to the delight of my children actually, because this light bulb supports, of course, we can do it's an RGB light bulb, yeah. We can change the color, hooray. And kids love that. But even better, this mode is called wonderful. What were they thinking? Yeah. There's a great presentation from Michael Bolton on critical thinking for testers from a test bash. Free PDF, download it, read it. This whole thing about challenging assumptions, not being fooled by biases. It's a great resource to work on that. And my final recommendation, follow the nice Twitter account, Internet of Shit. I'm not saying all of those things are shit, but it's a nice collection of things that go wrong, of people doing things, yeah, not everybody should be doing, of people complaining about firmware updates for their smart mug. They can't drink their tea because the firmware update's still going on for half an hour. Don't end up on that Twitter account, then you've done something right. But it's a great learning opportunity. And that's all from me. Please rate this talk. Tell me if you liked it. Tell me if you didn't. What? It says 2017. It's the official slide. I didn't want to mess around with the official slide. But yeah, you found a bug. Thank you very much for your attention. Yeah.